Hey guys, welcome to today's video. Let's do another Leetcode problem. So this is today's daily challenge problem. What is this problem? It's basically asking the number of combinations or more like the number of distinct ways in which you can climb a set of stairs to reach the top, and n is the number of steps till the top. And the condition is that you can climb either one or two steps at a time. It's like what are the number of combinations of one and two distinct combinations which you can form, which will sum up to n. That's another way of framing this problem. Yeah, let's just think how we can do this. So let's take let's just imagine these are the steps, right? So this is the nth step, and this would be n minus 1 and n minus 2 and so on. Now think about the nth step. How can we reach here? Like what are the possible previous states before I reach here? So we know that we can either take one or two steps. So that means in order to climb to reach this top step, we could either have climbed from here by taking one step. So from n minus 1, I take one step and I reach n. Or I could have climbed from n minus 2 and directly taken two steps. So I went from n minus 2 to n, right? So there's only these two ways. And this could apply for any of these steps. Like even if I take this some step in between, let's say this is m, right, which is less than n. So to reach m, I could have taken one step from m minus 1, or I could have taken two steps. I could have taken like two steps in one go from m minus 2, right? So this applies to any step. Once we have this idea in mind, then we can think of the solution. So the question is asking the number of distinct ways in which you can reach the top. So if we if there were, let's say, some x number of ways to reach the n minus 2 steps from the bottom, right? We don't know what that number is, but let's just say we have that number somehow, right? So the number of distinct ways in which I can reach the n minus 2 that step is, let's say, m. So 2 ways to reach n minus 2, let's say that's some m number of ways. Now we're not talking about the number of steps. We shouldn't confuse that. We're talking about the number of ways in which we could reach n minus 2. So I might have what I mean when I say m is actually let's say in order to climb to n minus 2, I might have taken, I don't know, I kept taking one step, right, till n minus 2. So this is one way. Then I might have taken one, then two, then 1, right? This is another way, and so on. So all of these, like the different ways in which I can climb, when I sum all of them up, that sums up to m, like the number of ways, right? So that is m. So we shouldn't confuse the number of steps I've taken. So I'm thinking, so I'm denoting number of ways to reach n minus 2 as m, and let's say in the same manner, ways to reach n minus 1 is actually, let's call this x, and we'll call this y. So if I know these two numbers, let's say I somehow knew them, then the number of combinations or number of ways in which I can reach the nth step would be just x plus y. Now let me explain why this is, if in case it's not clear yet. So I could have only come from these two steps, that we've established through the thought experiment. So if there were X number of ways to reach till this point, for each of those ways, I could have come like 1, 1, 1, 1, 2, 2, 2, 1, 1, and so on. So for each of those distinct ways, each of those combinations, from that I can take 2 steps and reach here, which means all of those X ways, right? All of these X combinations, if I append 2 to each one of these, right? That means whatever was here, and then I finally add another step, which is 2 steps, then I could reach n, right? And these would be valid, like each of these are distinct. So if I add 2, each of these are again distinct, right? So that means each of these X is valid. I can just add 2 and then reach n. In the same way, to reach n minus 1, I would have Y ways. So let's say again, to reach n minus 1, I had these many different combinations. Now to each one, I could have just taken one more step of size 1, and then I'd be able to reach the nth step, right? So again, each of these Y combinations, I could just add 1, and that would lead me to the nth step. So we have the number of distinct ways to reach n is equal to number of distinct ways in which you can reach n minus 2 plus the number of distinct ways in which you can reach n minus 1. So that forms the basic equation with which we'll be building this solution. So we can go ahead and implement this. So what we want to do, as is typical with dynamic programming problems, is we want to store the results of the values which have been computed, and we're going to start computing them from the lowest values, for which we already know the solution. So let's say I have, I'm going to store it in this member of this class called numWays to top, and we're going to make this a dictionary, but in fact we can already store the values. So what this maps is, it maps from n to the number of ways to reach, to climb till n. So we know that if there's just one step, we can only take one. If there are 2 steps, we could climb it in 2 different ways. So if there is only 1 step, we could only take 1 step, right? If we were to take 2 steps, it would go beyond that. If there were 2 steps, we could do this in 2 different ways. We could either take 1 step and then another step, or we could simply take 1 step which is of the size 2, like 2 steps in one go. So hence the count, right? Yeah, I mean, we know for 3 as well, but we'll make it calculate for the rest. So this is where we're going to store all our values, and we're going to write it recursively. So let's just call the function numWays, and top step is the input that goes in. So we see if it has already been calculated. That means if top step in self dot number of ways to top, so if it already has been calculated, there will be an entry there. So we simply return self dot of top step, right? Now if otherwise, if it is not there, what we do, we're going to compute it and we're going to store it. So number of ways equals number of ways to reach the top of top step minus 1 plus top step, where did that go? Top step minus 2, right? And we're going to return it after that. Okay, I can actually clean this up, but we'll leave it like this. Okay, so I think that completes the implementation. We just need to call it and return. So return num ways of n, which is what we want. So for instance, if we had gotten 3, it would have come inside this. 3 would not be present, so we would compute that. So number of ways of 2 plus number of ways of 1, which are already there, which is 2 and 1, so it would sum up to 3, and we're going to store that. Let's say if this was called for 10, then it would come inside this. It would see that it's not present, then it would check, it would call for 9 and 8, it would go inside 9. 9 is not present, so it would compute 8 and 7, then 7 is not present, and so on till it reaches 3, which would compute for 2 and 1, which would sum it up from 2 and 1, and then it would keep on building. So this should work. All right. Okay, lucky me. So that was my solution. I hope you liked it. Please let me know in the comments if you have any feedback or if you have any alternate solutions, and please subscribe if you want to see more solutions like this. Thanks for watching. See you guys in the next one.